Hello students, in the previous class we learned about two contact forces, tension and normal reaction. Today in this class we will learn about two more contact forces. One of them is friction and the other one is force due to collision. But before we start, I would just like to tell you that here we are just familiarizing ourselves with the type of forces and we are not going much into the details of the force. In this context of the class 8 syllabus, we will be just familiarizing and not going into the depth. In higher classes, when you will be learning more about the forces, there also you will learn the nature of the forces which we are learning and how to use those forces in the numerical problems. So now let us see what is friction. So friction is yet another example of contact force which tends to oppose relative motion between the surfaces in contact. For example, when I rub my palm together, my upper palm or the right palm exerts an opposing force on the left palm and the left palm opposes the motion of right palm. This force which opposes relative motion between the surfaces in contact is known as force of friction. And this force always acts along the surfaces which are in contact. For example, here both my palms are in contact in horizontal manner. So the force of friction will also be horizontal. So not much bothering about the directions of friction, that will be used further in higher classes for solving numericals. For here, class 8 standard, we have to just learn that it opposes relative motion between the bodies and it acts along the surfaces which are in contact. Look at this chair. This chair is right now at rest on the floor. When the body is at rest, it means that balanced forces are acting on it. We have learned about weight of the body which acts downward and normal reaction which is given by the surface in contact in upward direction. In this condition, the forces on the chair are weight of the force which is pulling it downwards and normal reaction which is pushing it upwards. Both the forces are balanced and that is why the chair is not moving. Now look at this condition. When I am trying to push this chair a little, I am trying to push the chair a little and I find that the chair still does not move. Why is it not moving? It is not moving because when I am pushing it towards right, there is an opposing force towards the left which is not allowing it to move. This force is the force of friction. And this is also known as static friction because it is acting on the object at rest. When I keep on increasing my force further, there is certain condition where the static friction is overcome and the chair starts moving. But still I find that there is some opposition to the motion of chair. This opposition is known as kinetic friction which is acting on the object which is moving. We have also seen kinetic friction in case of a rolling ball. When we have a ball rolling on the floor, after moving certain distance, it comes to rest. This is because of the force of friction which is acting upon it. Similarly, when we leave a pendulum swinging for some time, after some time it comes to rest because of the force of friction which is provided by the particles of air. And those particles, they stop the pendulum. Friction is also offered by liquids and gases. About this type of friction, we call it viscous drag or viscous force. We will learn in the next chapter which is completely covering all the aspects of friction. Last type of contact force in our syllabus is force due to collision. The name itself suggests that it acts whenever two bodies collide with each other. Whenever two bodies collide with each other, they exert an equal and opposite force on each other. For example, this is some object A which collides with some object B. Object B exerts some force on object A. At the same time, object A also exerts some force on B. A पर लगने वाला force को हम इस तरफ दिखा रहे हैं. This is FAB, means force on A due to B. And this direction, I am showing the force acting on B due to A. According to Newton's law, every action has an equal and opposite reaction. Here, due to collision, both these forces FAB and FBA are equal in value, but you can see that they are opposite in direction. Sometimes you might wonder that what if a very light body collides with a very heavy body? For example, a mosquito comes and strikes this board. Will they exert equal and opposite force on each other? The answer will be yes. Even if a very small object collides with a very big object, then also they exert equal and opposite force on each other. Force on A due to B will be equal to the force on B due to A. But the effect will be greater on the lighter object. This is because of the change in momentum of the body that you will learn in higher classes. For now, you can just understand that the lighter object will experience a greater effect of force as compared to the heavier object. So this is just an example. Suppose you throw a ball towards the ball only bounces back, not the wall which moves. It is also because they are exerting equal and opposite force on each other, but effect is seen on the lighter body.